Hey everybody, today we are doing lesson 7.3, continuing on with our exponents. And we're still with multiplication, and today we have a power of a product property. All right, so what this is saying, if you have two numbers, let's call them x and y for this case, and if they are multiplying together, and they're both being raised to an exponent, well, then they both get that exponent, and they're multiplying together. So you can almost think of it like distributing in the exponent, right? But you need to be careful. If you are adding or subtracting anything in the parentheses, then it doesn't work. It's only if everything is multiplying. All right, so on this first example, I have xy raised to the third power. So that means x gets the exponent of 3, and y gets the exponent of 3. All right, so this is technically already saying x cubed times y cubed. All right, so either of these answers would work. When we put our variables next to each other without a symbol, we assume it's multiplication. All right, on this next one, 2x quantity squared. All right, you need to be careful on this one because the 2 gets the squared and the x gets the square. And we know what 2 squared is. It's 4. So really we get 4x squared. All right, and the reason this works is because 2x quantity squared would be 2x times 2x. Right, and the commutative property says if everything's multiplying, we can switch the order. So I could say 2 times x, which again would get us to 4x squared. All right, moving on to the next one, negative 3x quantity squared. So it's negative 3x times negative 3x, multiplying it by itself twice. So if I arrange this, negative 3 times negative 3 times x, we get negative 3 times negative 3 is positive 9 times x is x squared, so 9x squared. All right, if we had just followed our property rule, negative 3 squared, you want to be careful if you're using your calculator, make sure you put that in parentheses, and then x squared. All right, so with parentheses, that's saying it's negative 3 times itself. So negative 3 times negative 3 gives us positive 9 times x squared, and we still get our same answer. So on this fourth one, we have 4p cubed. So the 4 is going to get cubed and the p. So 4 cubed, p cubed. The reason being, if I expand it out, it's 4p times 4p times 4p. So 4 times 4 times 4 times p times p times p. So you can see we get our 4 cubed and p cubed. Now what is 4 cubed? Well, that is 64, and we still have p cubed. All right, let's do one more here. Give me a second. Let's do this before the challenge. All right, negative 5t squared quantity squared. So if I expand it out, negative 5t squared times negative 5t squared. And if I expand it out further, negative 5 times t times negative 5 times t times t. So negative 5 times negative 5 gets us 25. T times t times t times t gets us t to the fourth. Now if we use our properties, the negative 5 gets squared and the t squared gets squared. So negative 5 in parentheses squared. And then if I have a power to a power, all right, remember that's where we multiply the exponents. So it's t to the 2 times 2 power, which gets us t to the 4th. All right, so those are similar to the most common ones that you will see. All right, but let's just do some challenge ones just to see. All right, this first one, x to the negative 2nd power, y to the 0th power, quantity cubed. So if I use my exponent properties, a power to a power means I multiply them. So x to the negative 2 times 3, and y to the 0 times 3. So this gives me x to the negative 6 times y to the 0th. All right, I know x to the negative 6 is the same thing as 1 over x to the 6th. And I know y to the 0, or anything to the 0th power, is 1. So I have 1 over x to the 6th times 1, which is just 1 over x to the 6th. All right, another way to figure this one out is maybe I expand it out. X to the negative 2nd, y to the 0, and then 3 times because it's being cubed. So x to the negative 2nd, y to the 0, x to the negative 2nd, y to the 0, 3 times. Maybe you realize y to the 0 in all of these is just 1. So really we just have x to the negative 2nd times x to the negative 2nd times x to the negative 2nd. All right, and here, maybe you use product of a power. All right, so we're multiplying the same base of x, so that means we want to add the exponents. So x to the negative 2 minus 2 minus 2. Because if I'm adding a negative, it's the same as subtracting, which is really x to the negative 6, and we know that that is 1 over x to the positive 6. So either way, we get the same answer. All right, now this next one. Let's do this with our exponent properties. So a power to a power means we multiply the exponents. So x to the 2 times 4 power, y to the 3 times 4 power, times x to the 2 times negative 4 power, times y to the 4 times negative 4 power. So really we have x to the 8th times y to the 12th times x to the negative 8th times y to the negative 16th. All right, so this is where it might get a little tricky. I know my x to the negative 8th and y to the negative 16th can be rewritten. So I'm going to say x to the 8th, y to the 12th, right? And those are both over 1 times, now x to the negative 8th is 1 over x to the 8th, and y to the negative 16th is 1 over y to the positive 16th. So to multiply these 4 fractions together, we just go straight across. So 1 times 1 times y to the 12th times x to the 8th. That just gives us x to the 8th times y to the 12th on top. Over our denominators, just multiplying straight across, we get x to the 8th, y to the 16th. All right, so everything on top is multiplying, everything on bottom is multiplying. So to give you a visual, I'm just going to expand this out completely. So x to the 8th, 1, 2, 3, 4, 5, 6, 7, 8. Y to the 12th, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, now for the denominator, x to the 8th, 1, 2, 3, 4, 5, 6, 7, 8, and y to the 16th, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right, now the reason I expanded it out is to give you a nice visual, and we can cancel some terms off. An x term on top will cancel with an x on bottom. Another x on top will cancel with another x on bottom. In fact, the 6 remaining x's on top will cancel with the 6 remaining x's on bottom. So all the x's disappear. Now I can do the same thing with the y values. Take all 12 of these y values and cancel them off with 12 that are down below. So what did that leave me with? Well, that left me with nothing on top, but I can't just write nothing, because I could have had times 1, and it's the same thing. So really I have a 1 on top, and then y times y times y times y on the bottom, which is y to the 4th. So there we go. All right. That is it for today. And again, that is our power of a product property. So let's get started on the LT check and finish strong.